In this video, let's look at a technique for solving dilution problems. I'm Mr. H. Thank you for joining me. Dilution problems come in the form M1V1 is equal to M2V2, or you can say the initial molarity, initial volume multiplied is equal to your final molarity and the final volume, they're multiplied. And you know you have a ratio over here, but these type of questions are never generally that easy. If you have three variables, you can solve for the fourth. That's a general point behind these type of questions. But what exactly is our question? We have to find what final volume should you dilute 50 milliliters of 5 molar potassium iodide solution so that 25 ml of that diluted solution will have 3.3 grams of potassium iodide. Again, you have to find the final volume of a diluted solution. That diluted solution would have what final volume, so that if you were to look at 25 ml of that diluted solution, you would be able to pull out or generate 3.3 grams of potassium iodide. And the material you can use here is 50 ml of 5 molar potassium iodide. Just for perspective, if you're looking at this, what you already have right over here, 50 ml, 5 molar, how much potassium iodide is in here? Well, you know molarity is equal to moles over volume, and then moles is equal to molarity times volume. You can do that. It'll give you a perspective as to how much potassium iodide is in this concentrated solution. You do 50 ml, which is 0.05 liters. Always convert milliliters into liters, times 5. You'll have 0.25 mole potassium iodide, which you know is equal to mass over molecular weight. The mass over here is equal to the molecular weight times that. What's the molecular weight of potassium iodide? You just do 39 plus 127, the molar masses of each, which is 166. When you multiply these two, you get 166 times 0.25, you have 41.5 grams of potassium iodide. What you're seeing over here, your initial solution is so concentrated you can pull out to 41.5 grams, but you want to dilute it, so all you can do is from a certain volume you can pull out 3.3 grams of potassium iodide. How would you do that? Well, you would want to determine how many moles is this, because then that will come back into this whole formula right over here. 3.3 grams potassium iodide, you just do 3.3 divided by the molar mass, 166 of potassium iodide. You get 3.3 divided by 166, you'll have 0.0198795 moles. 0.0198795 moles of potassium iodide. But I know 25 ml of solution should have that. You can determine the molarity of that. Molarity is equal to moles over volume, which is equal to 0.0198795 moles divided by 25 ml converted to liters, 0.025 liters. When you do that, what will you get? You divide that moles by 0.025 liters, you'll have 0.7952. I'll round it up. 0.7952 molarity. Now you see I've determined this and I have this. All I have to do is determine that and everything will work out. I have MIVI, which is this. 5 molars times the volume 0.05 is equal to your final molarity, which I've just calculated using the parameters that I'm trying to obtain. 0.7952 times your final volume, which is to what final volume should you dilute. You'll just basically solve for that. Now it's just a ratio question and you'll be done. You'll do 5 times 0.05, the initial molarity times initial volume divided by your new molarity, which I had saved in my calculator. I'll get 0.314 liters. I'll multiply this by 1000 and convert it into milliliters. It'll be 314.4 milliliters. It's 0.314 liters, or it's 314.4 milliliters, and that's your final answer. To what final volume should you dilute this 50 milliliters of 5 molar potassium iodide, so that if you were to pull out 25 ml of that solution, when you've diluted it, you'll have 3.3 grams of potassium iodide. It's this right over here. And you've seen how everything has come about. That's what I want to present to you in this video. Thank you for watching.